Okay, yes, you see the slides. All right, so I will skip the rule because you are all regular members. So let's, this one is the sharing of the National Day promotion. All right, this whole month of August. So please do share the schedule and share the WhatsApp number and share the referral code with your friend. If your friend sign up, you got 25% off. Your friend also gets 25% off. Even if your friend doesn't sign up, your friend gets a free lesson. So your friend will still thank you for sharing. Okay, let's start. Let's start with starch. Now, starch is broken down into glucose, okay, in the small intestine, and then absorbed into the walls of the small intestine. All right. So which statement correctly describes how glucose is transported into the bloodstream? Okay. So over here, can everybody type your answer into the chat, please? Okay, what's your answer for this question? So basically, they're asking how they transport glucose. So is it now over here I have osmosis, I have diffusion. Okay, maybe you all type into the chat. Do you think transporting glucose is diffusion or osmosis? Everybody type into the chat, please. Thank you. It's okay to get the wrong answer. We are here to learn. All right. Nothing embarrassing about giving wrong answer. It's only embarrassing if you don't give an answer. All right. So can I get everyone to type in the chat diffusion or osmosis if you are using glucose? Bernie, what do you think? Is this diffusion or osmosis? Thank you, Eldia. Bernie, Hein, Charmaine, Wesley, what do you think? Is this diffusion or osmosis? Okay, so Eldia thinks it's diffusion. Diffusion need a double F, just a typo error. Bernie is osmosis. The rest, what do you think? Diffusion or osmosis? I'm not sure, just type not sure. So at least I know you're there. Okay, Wesley say osmosis. How about the rest? Okay, Charmaine? Charmaine and Hein, the two ladies, are you there? Charmaine, Hein, is this diffusion or osmosis? Okay, now, if always remember this word osmosis. Okay, osmosis is reserved only for water. So, in other words, you're talking about water moving, not anything else. All right, reserved for water moving from one place to another place. All right, so cannot be osmosis. Straight away, I put across because here I'm talking about glucose. Glucose is moving, water is moving. So is everybody clear? All right, it's okay to get this wrong today. After today, no more getting it wrong. So because you are moving the glucose, transporting the glucose, transport means moving, right? You're moving the glucose molecules, so you're not moving the water molecules. Osmosis is only meant for moving of the water molecules. Another thing about osmosis is it involves what kind of membrane? Can you type into the chat? What kind of membrane? Do you remember? It must have a membrane. The molecules pass through a membrane. What kind of membrane are we talking about here? Semi-permeable membrane. All right, whereas diffusion doesn't need a membrane. Diffusion, zero membrane, all right? But osmosis must have the molecules passing through, the water molecules must pass through a semi-permeable membrane. Okay, so anyway, I know A and B is definitely wrong because the word is osmosis. Now left is C and D. Now C and D talk about glucose is transported into the bloodstream via diffusion, double F, from a region of higher concentration to a region of lower concentration. The other one is lower concentration to higher concentration. So can everybody type your answer into the chat, C or D? Make a guess then. Don't make a guess. This one should be quite simple for everyone, C or D. Do the molecules move from higher concentration to lower concentration, or do they go from lower concentration to higher concentration? I give you a clue. Always think of waterfall. How does the water flow? How does the water flow in a waterfall? Does the water move from higher to lower place or lower to higher place? All right, so yes, the answer is C. So always move from higher to lower. All right, always. I don't care diffusion or osmosis, it's always higher to lower. Okay, so over here, take note that osmosis is only for water and there is a semi-permeable membrane. All right, so this question is talking about glucose. It's not water. Okay, maybe I shall not use blue. I shall use, let's say, green. All right, therefore it has to be diffusion. Cannot be osmosis, right? Because glucose is not water. All right, and then movement always from higher concentration to lower concentration. All right, okay, so I just run through a few slides. Some of these slides might be familiar to you, but it seems that some of you have forgotten. Never mind if you get this wrong. Today, after today, cannot get this wrong. Now, diffusion is for movement of anything. All right, can be really anything. All right, diffusion of sugar, diffusion of salt, diffusion of starch, diffusion of anything, even diffusion of water, anything. Okay, so always higher concentration goes to lower concentration. Think of water for high to low. So over here, anybody can remember what gas is this? This one, I take the opportunity to help you all remember. This one, you must know the color. It's a reddish brown color, right? A little bit of red, a little bit of brown. It's a reddish brown gas, all right? So in this case, can y'all tell me, all right, I give you a clue, B and R. Which element start with B? Is a B and R, R and B. So which element is this? It start with B and R, all right? So B and R, that's why it's reddish, right? So you see there is a R, R stands for reddish. There's a B, B stands for brown, all right? So reddish brown. Okay, and then it's 2 by 2. All right, so this is actually bromine gas. Y'all need to know bromine is reddish brown. All right, so B and R, reddish brown. So there's a lot of bromine gas here. Okay, Br2, Br2. If I draw it, it's 2 by 2, 2 by 2. All right, 2 by 2. Okay, here only air, colorless air. There is no reddish brown. Okay, so we have watched the video before, am I right? So you will see the reddish brown bromine gas. All right, bromine gas will diffuse upwards. Because there's so much bromine here. There's zero bromine here. All right, so the movement is always from a lot to higher concentration to lower concentration. All right, because so many bromine here, so squeeze here, they want to spread out. All right, so air will diffuse downwards. Reddish brown bromine will diffuse upwards. All right, is that clear? Okay. All right. Okay, now let me just check the attendance. I have, yes, 5 of you. Hein, I think your internet is laggy, right? So you went out for a while. You all hear the ding dong sound. It means that someone is coming into the Zoom room. Okay, so this slide is important. I want everybody to remember the color of bromine. You need it in set 3 and set 4. All right, so reddish brown, and I already given you a memory aid. All right, so R is reddish, B is brown. So reddish brown, all right? So reddish brown bromine. Okay, now difference between diffusion and osmosis. Diffusion is movement or anything, all right? Osmosis is reserved just for water. So use osmosis when you're talking about water moving. So actually osmosis, this word equals to, is the same as diffusion of water. So it's water diffusing. All right, water diffusion, because it's water, I give it a special name called osmosis. So osmosis is reserved for water. Please remember that. So water will also move from higher concentration to lower concentration. So here is higher water potential, all right, to lower water potential. Okay, so you can use concentration, but most teachers prefer the word potential. Use the word potential when you use water. So what is water potential? Water potential instead of water concentration. All right, so for water, we use the word potential instead of concentration. So water potential is to measure what is a tendency of water molecules to move from one region, one place to another region. Right, move from one place to another place. What is a tendency of water? Now, this is the interesting part. When you have a lot of solute, like a lot of sugar, a lot of salt dissolved in the water, then the water molecules will be bound to the sugar and bound to the salt. That means the water molecules will be to the sugar, stuck to the salt, but you don't use the word stuck. All right, it's bound, it's bonded, okay? So therefore, there'll be fewer water molecules moving freely. All right, so in other words, if your solution is very, very, very sweet, a lot of sugar dissolved in the water, your solution is a concentrated solution, very, 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 very sweet, like Ribena like that. All right, Ribena solution. Then your water molecules inside will be stuck to the sugar molecules. All right, so when you have so many sugar molecules, you will have many water molecules stuck to the sugar molecules. All right, therefore, there'll be fewer water molecules with freedom to move around. All right, so because most of your water molecules are stuck to the sugar molecules, if it's a very, very sweet solution, very, very concentrated Ribena solution. So if you have a concentrated solution, like very, very sweet or very, very salty, it will have a lower water potential. Why lower? Because you have fewer water molecules that can move freely. All right, so let me use this to give an example. So let's say here is 10% sugar solution. Not so sweet, only 10% sugar. But here, this part, all right, is 40% sugar solution, is sweeter. If you drink from the water here, it's sweeter, 40% sugar. Here, only 10% sugar, less sweet. This part is less sweet. Here is very, very sweet. All right, so I'll write here very concentrated sugar solution. So you see the red color is the sugar. Wow, so much sugar, very, very sweet. Here, less sugar dissolved inside the water, less sweet, so very diluted sugar solution. So inside 10%, assume that you have 100 water molecules. I'm using numbers to help you visualize. Of course, there'll be much more than 100. So you have 100, the blue color is the water molecules. So let's say you have 100 water molecules and you have 10 sugar molecules. All right, 10 sugar molecules. Solid can be sugar, can be salt, can be anything. All right, sugar, salt, starch. So 10 sugar molecules dissolve inside 100 water molecules. Now, since you have 10 sugar will hold on to the 10 water molecules. All right, the sugar likes water very much. Sugar will control of the water and will not let the water molecules move freely. So 100 minus 10, I will have remaining 90 free water molecules with the freedom to move freely. Free means got freedom, can move freely, can go anywhere. All right, so I got 90 free water molecules. Then this is for this part. Then this yellow box is for this part, the right-hand side. Again, I have 100 water molecules, same amount of water, but I dissolve more sugar, 40 sugar molecules. So these 40 sugar molecules will catch hold of 40 water molecules. Sugar loves water, okay? So 100 minus 40 is 60. I will have 60 water molecules with the freedom to move. So here I got 90 free water molecules. Here I got 60 free molecules. So therefore, the water molecules will diffuse from left to right. They always go from big number to small number. So imagine 90 people here squeeze here. Here you got 60 people here squeeze here. So the one that is more squeezy, right, the people will move over, right? So it will go this way. So the water will move from left to right. All right, so the water will move from here to here. So this is the movement. I've written here, water molecules move from here to here. So therefore, you will see more water here. The water level will rise. So water from here will move here. So here you see more water, higher water level. All right, so then you'll be asking me, then Miss Ivy, but then why here got 10 sugar? Here got 40 sugar. How come the sugar cannot go this way? Here 40 sugar, 40 is a bigger number than 10. So here so squeezy for the sugar. Why can't the sugar move over? So many sugar here. Why can't the red color sugar move over? Can you type into the chat? What is the reason why the sugar cannot go over? All right. Or someone wants to unmute yourself. I'm fine also. Can you explain why there's so much red color sugar here? Here there's less red color sugar here. Why can't, here is so squeezy with the sugar. Why can't the sugar molecules move over? Here I got 40 sugar molecules. Here I got only 10 sugar molecules. Here got so many, 40 is bigger than 10. So why can't the sugar go over? Can I have a response, please? It's okay to give me wrong answer, but at least you try. All right, can you type into the chat, why can't the sugar go over? Or you can unmute yourself.